Okay, hello, good morning. I'm working on something really cool. It's related to like how to express state machines in general, specifically transitions. Because what I notice is that I've been trying different signatures to subscribe to some transitions. So for example, you subscribe by like giving the state you go into, and then you could optionally do like the action or the event, and then you could also, oh, if you're coming from this state. But this is like, this doesn't describe anything. And then yesterday I was trying like from foo action switch to bar, for example. But then I had issues in the callback, like do I call it like to an action and stuff like that. It was confusing, and actually expressing like in the actual app, CodeSandbox Projects app, it was also difficult to reason about from and to. Sometimes it was like the story you wanted to tell was like from and to, and other times it was more like target. And you could like optionally do any of them, and what does that mean, and so on. So I found another format which is super interesting. I'm not going to show it yet. I'm going to try to wrap up the implementation because I'm almost there, and then we can rather look at the test. So let's see here. Yeah, let's see. If applicable. So I have this thing, and so we need to figure out has changed within states. So I don't think I actually care about this anymore. No, I do. Yeah, so this would actually be has changed within states. But this could be either if you have a single state, but we also want this to happen yeah, I think we want to do this as well. So this is either if we have that single state or if we have a specific transition. Okay, let's try it first. So this is like a single, and then and this would now be prev state. Yeah, has changed within states, and then has changed to state, and that would be, yeah, it's the same, but we're going to say transitions. A string. It's basically the same thing. So we have this or this. Yeah, but oh yeah. Let's see. No, we have to change this. because there are two different formats to this transitions array, and the way it maybe we should just state should transition. How should we do this? God damn it. Thinking. Yeah, maybe this is a bit boring if I keep it secret. So I can show some of it. So this array either has like foo, it can have foo bar, it can also have this format, switch bar, and then like the opposite, bar switch. And what I want to check is if it's a single state, I want to trigger the callback only with that state. But if it's this format, I want to trigger it with the params, basically this one. So maybe we should so has changed within states, that's the same. So if I were to express, it doesn't matter, like blip, bloop. So if I was in bar, and yeah, no, that could never occur. Yeah, like, and if I had something like this, this could happen. Then should that transition trigger? Yes, it should. Yeah, so it should always trigger. It's only these ones that should not trigger. Okay, so I just need to yeah, exactly. Has changed within states. This is the one. This is the only reason to. Oh, I have to close the window. Yeah. So this format basically dictates that as long as you stay within either of these states, the transition doesn't trigger. But this format will always trigger. Doesn't matter. So basically, yeah, so I guess and we don't actually have to check this. I'm thinking. Has changed to state. Because we don't need this check, because that's already checked up here. So if we have actually just changed to the state, we want to do this thing, and we can call it has changed to explicit state, explicit explicit, let's just call it that, and then we'll return. We can do this, and then if, and so that's the thing, like if we Yeah. And then the transition is expressed as, yeah, okay, so of course, current state, state, event.type, and then prev state, state. Okay, so then we can check, yeah, basically, okay, we don't even, okay, sorry, I'm messing around here. Transitions includes that thing, and then we can just check this. Okay, I think this is what we need. And then we can just do like this. And then we'll return, oh, we'll return here. There we go. Okay, I think this is the logic. So let me show you what I've done here. What I realized is that everything we tried to express with transitions was based on the completely separated state and events. Like this is Timsy, so we talk about events here. But we're actually able to infer the exact transitions that's possible to do, which is amazing. So you don't have to reason about these transitions. They're just given to you based on your definition. So if we go in here and we look at these subscriptions, and for some reason this is effect never. Okay, what the hell did I do here? Effect. Oh, didn't I? Oh, sorry. Or string. There we go. Oh yeah. God damn it. We have to ss extends string. Oscar is home today as well. My partner is going a little bit crazy. So I have to help out some more. And today he's actually just fine. He could have gone to kindergarten, but there's a rule that he can't do that. He has to be like in good spirits for one day. And that's exhausting, staying home with a 1.5-year-old who's got a ton of energy. Should trigger when entering state by event. Yeah, so actually we don't care about... let's drop this one. Because what we're going to do now is I should magically... You see this? This is awesome. So it infers that, okay, I can do a subscription on entering a state regardless of how you get there, including the initial state. So if it starts in bar, it will trigger immediately as well. But I can also get the exact transitions inferred. So in this case, was it bar? Yeah, you see that? And then this is actually typed to bar. This is typed to switch, and this is typed to prev state. Like they don't actually have anything, as you can see here. But if I add arguments here and so on, that's amazing. And that's the thing, like this just has a very natural, arguably a natural meaning for us. It's like in every single version I tried to express these transitions, I haven't been able to, like this is how we typically think about transitions. You're moving from bar, you're getting a switch, and it ends up in foo. So that just simplifies a ton. And one thing I wanted to check though is what if I do true? Does it understand? Yeah. Yeah, foo switch foo. This is awesome. And I can like even search. So I want something related to switch, right? So you can even search it. That's amazing. You can like search the exact transitions. I'm super excited by this. Now, this is definitely what we're going to do. It's of course a breaking change, but it's so awesome that it's okay. So here we have a bar switch. What am I doing? So we're starting in foo and we're switching. Oh. Yeah, so this should handle multiple states with event effect. So this doesn't work anymore. And it actually doesn't make sense because now suddenly like you depend on switch, which is a little bit weird because what about the initial state? So what you would have to do here if you wanted to react to both of these things, you would rather do the let's see, we would rather do foo switch to bar or bar switch to foo. These are the two things I want to deal with. Let's try to test this. A couple of them fail. Which one is this? Should trigger when? Okay, this is core. And event from state. Okay, this one failed. Let's see. Let's yarn test and watch this. And the thing is, like, what I'm excited about is if we can do the same for React states, because React states, I'm not sure if we're able to do the same inference there. It's something I need to figure out. Should trigger when set by event from state. Expect assertions. Oh, sorry. I thought it's when we move from foo to bar. From state. And this should have been empty, but it wasn't, which means we did something wrong. Which is weird. What? Let's look at the. So we got that thing, current state. Event prev state. State bar switch to foo. How can that fail? So we're getting down there. Oh, sorry. I know what it is. It's this should be transitions. Okay, now we have 0 assertion calls. Okay, so it still failed, but now it should at least be... What? Let's see. We have transitions. Foo switch. Oh, sorry. Yeah, I'm putting these the opposite way. My bad. Of course, we're switching from something to something. Oh, we need to put that down here. Oh yeah, and in that sense, we actually have the arguments are opposite. Yeah, we need to change the order of the arguments because I want the arguments to reflect the transition. So where are we? Transition. Here we are. So this should be opposite. First we get the previous state, and then we get the params for the action, and then we get the current state, the final state. But in the other ones, you just get the current state because you don't know if it's like initial or one of the others. And when expressed that way, you don't really care about the other stuff. And if you need to do a very, very specific transition, you can always go low level and look at the exact. Yeah, so we should probably change it there as well. Let's see. So we have subscriber here. We should change this as well. So it starts with the previous state, then we get the event, and then we actually get the new state. Because that just follows the transition mindset. It's like you move from one state to another state. Even though you're most likely want to use the final state, it just fits with the model. Yeah, it's interesting. You could even... Yeah, maybe that, like I'm trying to reason about what's the... No, I think that's correct. Like you should always think in transition. Like even the arguments is a transition or reflects a transition. But that means we have to change the implementation as well. So when we... Let's first change this one. So when we return subscribe, so let's change the order of these. Current state, that's okay. But I'm a little bit curious of where the hell do we trigger the callback? Subscribe. So here we should also get in this order. Where the hell do we trigger? There we go. Let's see there. Okay, because I've been back and forward on this quite a bit. Like, how do you like reason about this? Cool. Okay, so now we have that in the correct order. So this should be, and I want to say prev and current. So I want, so it actually, as you can see, it actually reflects what we see in the transition. Cool. And then in the React test, which one was that? With event. Was any of these ones using the, which one was this? 151. Received one, run bar effect count. How is that possible? Let's look at that one. Because it hasn't run switch yet, so that shouldn't be possible. So this shouldn't trigger at all, really. That's weird. Why does this trigger? Let's log in the test. Was it that one? No, it was in the React test. Just in case we have, yeah, the subscription triggers. Oh wait, we have a core test here as well, sorry. What the hell? What? Okay, so we have a core test. React test. How do I? Let's fix the. How do I do this? Can't I just react.test.ts, something like that? Yeah. Okay, so we're only running this one, and for some reason, yeah, we're getting but somehow it has run this thing. How is that possible? And it was not based on, so it must have been this thing that did it. Yeah, how is that possible? Oh, sorry, this is using the wrong, oh, it's using the wrong thing. It's supposed to use this one. So it's just, this is just to see, do I have like the current state in the transitions? Okay, cool. And now we have the other stuff that failed. So should emit event. Yeah, so I guess, yeah, this is now, this should be prev current. With event effect. What's that? Oh, React. Should handle state with event effect, true. Yeah, so this is just the wrong one. This is about moving from foo to bar. There we go. Okay. So I'm happy about this. We should make this breaking. We need to update the documentation. So we can do that quickly now. Okay, make state predictable. Yeah, so we can still do loading here. That's perfectly fine. Yeah, I actually don't have any. I don't actually have. Oh, core API. When exiting to yes, so here we would have foo switch bar. So this would be prev and then current. When and here you can also actually do, there's no reason for you to not be able to do this. So when you enter bar through this transition, whenever you get out of that, you can dispose of this. Good morning, Adam. Did you see the thing? Like we can infer all the transitions in Timsy, like the exact transitions. So you actually get a list of human readable transitions. And they are exactly the ones you defined in the machine, instead of you trying to like express when you're in this state and this event happens and you move to this state, and it might not even be valid. Like that transition might not even occur at all in the machine. But now we get two things. We get like a very human readable version of the transition, and it's ensured that that transition actually exists in the machine, which is awesome. Let's see. So this would be when either. Yeah, it's crazy, right? And this is actually typed. So what I do is that when we produce this object here, I have a type that transforms this into a template literal and populates all these transitions and these things here. And then when I want to produce the arguments here, and they are actually typed to this thing, I extend that template literal and I infer each type in here, like foo and switch and bar, and then map them to like their original types. It's crazy, but it works. I actually seen people, yeah, literal expressions, exactly. I actually seen someone that you can, what did they do? You could take an object and then you would actually get the JSON representation as like a template literal or something. I can't remember exactly what it was, but they are super, super powerful. So if I were to like, let's see, where's an example? Oh, yeah. So for example here, if I were to change this, like it immediately, yeah, mind blown, right? I played around with this before and then it suddenly hit me because when I started the stream, I was like reasoning about, okay, we first had this thing where you could do like, okay, I entered foo, that's one type of transition. And then, but okay, it happened through this action, and then, okay, but I came from this place. And then just reading this and not knowing the library, like it's hard to reason about. Like, is this the thing that I came from, and then this action, and this is where I ended up? Like, what's the order here? And then I tried to switch it to like an object where you would say to foo from bar action switch, but putting that in examples from CodeSandbox, I was like, should it be called to? Should it rather be target? Like, I couldn't match. And then consuming it here, you would have to from. It was just really weird. Yeah. Full IntelliSense. Like, look at this. It's beautiful. And you can even search it. Like, oh, I want to do something related to switch. And then it's filtered. Or I want to do something related to bar. Okay. These are the transitions available that affects bar. It's crazy. I'm so happy about this. Let's see. Ready to ship. So what we're going to do before we ship this one is we're going to see if we can actually infer transitions in React states. Yeah, it's amazing. Yeah, it's so cool that they implemented this in TypeScript, and like, and what you can apply it to. It's one of those features, and it's kind of like you think about this as different things, like the state, the action or event, and then the resulting state, and they are like different entities. But this is what I love about TypeScript, is that they have these features that allows you to create these abstractions, especially these what do we call it, template literal expression thingies, literal expressions. Like, it's all about figuring out ways to make things more readable, and that you're actually able to use this to produce like something like this. Suddenly now you have a type, like you have, like, how should I, it's almost like you now suddenly have string types. And these string types, they can be anything. They can be like emojis, for God's sakes. It's like, as long as what they represent can reference something as a string, in this case, like the state property and the type property on an event, you can do all kinds of... Yes, so it's all combinations. And I thought about this for... CodeSandbox Projects, because what we do there in the reducer is that we type every single event coming from the environment interface. Like, we're changing that approach, but the point is that's what I want to check, because I want to infer the transitions. So in terms of if it was to infer every possible transition, this wouldn't work. Not every possible, but every potential transition, right? This wouldn't work. But in a state machine, you don't have a lot of, like, you have a lot of potential transitions, but you don't actually have that many implemented. And those are the only ones that are inferred. It's the exact transitions. It's not the potential transitions. Yeah, DSL, that's type. Yeah, you should definitely play around with this. Yeah, and you can do stuff like, I actually had that in here. Like, what if I did this? Like, this could also be a type. Like, I don't care about where I came from and what action it is. I just care about entering this thing. And you could do that as well. And then you can just, you infer everything here every step. I can show you the code for that. It's really cool. You see here? So I check if this type extends this literal, where I infer every section of that template literal. It's crazy, but it's amazing. And then you could check, okay, does S extend asterisks, for example? Yeah. Yeah, it's cool stuff. Let's see. Let's jump to React states here and see if we can. Let's see. I was actually playing around with this. What the hell have I been doing here? I think we can. Well, first we have to, actually, I think we're going to create a new branch. Origin main, git checkout, readable. Oh, don't save. Don't save. Okay, but this is the thing I'm pretty curious about. I want to see if I can infer the transitions, because I'm not sure if I'm actually doing that now. Let's see. So, because now what I'm getting back on this state, that's the thing. This state object doesn't currently have the transitions. So we need to have those transitions as well to be able to infer it. It's kind of interesting that the transitions doesn't necessarily need to be there, like the actual object, but to be able to infer it, it needs to be there, because that's the thing about React states, is that we only have this state object returned from the reducer to work on, which is why we need these symbols. We don't have access to anything else. Let's see. So we have the transitions here, and I think we should be able to I think we should be able to infer the exact transitions. So we're going to try that now. We're going to steal this. Where the hell is it? The thing that actually builds the... No, this one. That builds the possible transitions. Yeah, I already have a T readable transition. Let's see. How will we do this? Yeah, that's the thing I don't quite like, but wow. That's... How did you... How... Okay, two questions. How long did it take to figure out that was the reason? And second question is, how did you actually figure out? What was the aha moment? Okay, so what I suggest we do here is that we just bring in the readable... Oh, it's one. just bring in the readable transitions, because this doesn't actually need to be a value. Like, this needs to be a value, but this doesn't actually need to be a value, because it's only to infer the typing. So let's see what we do here. So we're getting, so we're going through each state here. This is each state. Then we go through each. Yeah, so it's not a return type of a return type, but it's just return type. That's the problem here. What did I do? What did I do? TSA. And why doesn't that work? Type undefined. T extends, T transitions. Not that long then. But it opened in 1994. 1994. That reminds me, I'm actually watching X-Files episodes now. I'm hooked. That's back in the day. 1994. The 90s were also great. I would love to have been like a teenager in the 80s. That would be even more amazing, I think. I romanticize the 80s. My brother is 11 years older than me, and he was actually a teenager during the 80s. Not in our code, but data we consume. Yeah. Interesting. Oh, yeah, so this is... Okay, cool. So this is where it's... yeah, just for the music. Yeah, that's what I do. That's one of my... at the assembly with CodeSandbox, I was a self-proclaimed mood manager. And a lot of that has to do with music. And it doesn't matter who you're with. If you put on some good 80s music, everybody likes it. Okay, so this is the thing. I think we possibly have to rethink this a little bit. Because what we're doing now, we have... Yeah, exactly. So this is the problem. We are not actually inferring the transitions. So this type should actually be this. We are inferring them. Which means that this shouldn't be optional. Oh, wait, is that the reason? Oh. Okay, no, it has to be optional. How will we do this? No, it needs to be optional, but we just have to take that into account here. God damn it, this is... A extends string. How will I do this? Okay, so we need another check here. Let's see, let's copy that. Return type extends iState. Oh, no, that's wrong. But almost, we don't do return type. We just check if this extends. I think we could say, let's just do this. So if it extends, if it actually extends a function. Yeah, and it should return iState. That's more correct. Okay. So now I think we're actually able to... Yeah, exactly. And now we can take this and we can add... Okay, we're getting there, I think. So we have action. Now we have transitions. And that would be T-readable transition T. Cool. Now we have that. So now we should be able to infer this type. So that means when we use the transition effect, we should be able to go and grab this type instead. I have a bunch of stuff here that we can comment out. So let's try. Yeah, we'll have to redo. Oh my god. And that actually, yeah, it will be a much simpler implementation, which is good. So export function, use transition effect. So let's just do. Yeah, okay, this is gonna be nice, I think. So what we're getting in here is, oh my god, I'm so excited about this. I sometimes, yeah, I just love, you know, when you have sometimes, well, more often than not, clever solutions are, well, that's why we call them clever and not good. But there is this place where you can achieve cleverness and it being a good thing. And even though we need to like test this, I have a feeling that there's a high probability that we found that narrowed space of being clever and it actually being a good thing. We'll see. We'll see. Okay, so the state here needs to be S. When we have that state, we should be able to go and extract. We should be able to go and extract these transitions. So let's just try grabbing it. So the second one would be, let's just call it SS, extends S type of transitions. That should actually be all. So it can be an array as well, but we just want to see if we can get this thing running. So how can we check that quickly? We can create some state here. So state is foo, state is bar, and then we have type action called switch. And then, okay, let's just write it out. We have our reducer, which is state action, and then we do a transition of that state and action where we do foo bar, and we decide to do switch, which moves us. And this is the thing, like we have this explicit typing, which I have a feeling is going to break this, but let's try it. We don't have to do that. Bar, because now I think it's able to infer it, but if I do this, the inference breaks. So I think there's a cost benefit to this. Foo. Okay, so now we have the reducer. How do we actually do use transition effect here? Is this TSX? Yeah. Okay, my component equals const state equals use reducer state. Yeah, and this, I'm so flabbergasted by this. Why why isn't this typed? Why don't I get IntelliSense on this? Like it knows the return type. I believe. Like, is it? Oh wait, is it because we don't do this or? Oh, maybe that's the reason. No. Why don't I get IntelliSense on this? I just don't understand this. Yeah. Anyways, but I do like. I get type safety, but I don't get IntelliSense. It's weird. Anyways, so use transition effect, state. Ha! Did you see that, Adam? That was a little bit impressive. Was it? I think I'm in the zone today. I'm in the zone. And we actually got, yeah, so the question now is, if this is inferred, what if I remove this? It's actually inferred. Awesome. But let's try doing this now to get exact return type. What happens now? Yeah. Foo. Switch foo. Yeah, exactly. So this is the cost. If we have explicit return type, it basically says this can be okay, so with this approach, the cost of doing this is that we add another symbol to the state, which is like negligible. But we can't have exact return types, which is kind of a good thing, because it's kind of annoying that you have to do this. And so what I mean is, like, now I can do mip mop, and that's perfectly fine. But if I were to do this, it yells at me. If I do this, no, that doesn't matter. Yeah, so that's the bad thing. So if you were to like refactor the bar state and remove like a property, it wouldn't yell at you. But there is a better pattern. So instead of creating a state type like this, you could rather, like as described, is that you can have state creators instead. And then, so it works kind of like Timsy, where you basically describe your state as, did I have a, no, I didn't have a utility for that. Or did I have that? Where's the documentation? T transitions. Yeah. Pick state, pick action, pick. Oh, this is old stuff. Yeah, no, I don't have. But maybe that we could do that. But the point is that you would rather express your. You would rather say states, and then you would do foo. And you would say, but the problem here is that you have to repeat it. And then you have to make sure like these two has to be like the same, which is why Timsy has like create states, because then you don't have to add this part. It will actually do it based on the key. Okay, because I don't have that much time today. Oscar is still home, so I have to take care of him a little bit, so I can think about this in the meantime. But okay, so what you could argue is that you don't have to add the return type here, but if you want type safety on your return types, you don't express your state with a type. you rather do it as like factories. Yeah, and maybe that, because I want this to be low level, so you rather do this, like you do foo, and then that's just something you have to ensure yourself that those match, the key and the state. And then what you do is that you rather say state is, what was it? I had this really cool return type. What was this? Yeah, return type, key of type of states. Oh wait, type of states, key of type of states. Yeah, so this gives us the same. So we do foo, let's see, let's finish that one. Bar, and then we should have the same here. Yeah, so what you do is you say, now you can say states foo, and bar and states. So what you get now, you get both of them. You get type safety, you get an exact return type with that type safety, because now anything you want to be able to pass into a state, you have to pass it in here as an argument. So it solves, it also solves things like destructuring issues. But, oh, wait a minute. It didn't work now. Oh, that's sad. That is sad. Why didn't that work? Why did not that work? Why is this considered different? It's the same thing we return. Oh, sorry. That's the thing. You have to make it a constant. That's the thing. So what a utility does is that you don't have to write this. So one thing is making these two consistent. So my argument is like, maybe React states should should have a create states function to allow you to express states this way, because it gives so much more, there's so many benefits to it. And then with that, it could also expose a utility where you say just states and type of states. That's the state. And then you would have create states like this, and you didn't have to do anything. So it's not because you can't, like you can do the other thing, like you don't have to use this if you don't want to. Yeah. No, I want it to be low level. That's the thing. I want it to be low level. But it really annoys me with the return type. But that's the thing. Like React states is built to be like your stepping stone into state machines coming from a reducer. It's more of a, I consider it like a transition library. Because I would definitely rather use Timsy. Timsy is more powerful. You get it's a lot less code to express the same stuff. It's a bit more optimized because you're not tied to the reducer. So you don't have to like in the reducer, you have to, even though to trigger the use transition effect, you have to return new state from the reducer. So you have to reconcile the component again. But in TeamC, it's just a subscription. So the effect actually runs without the component reconciling. So those are kind of like the costs. But I think... Yeah, I'm struggling a little bit. Yeah, I think like it would be more, that's the thing. I actually have a value in React states. It's tied to... Oh, why have both TeamC and React states? Yeah, good question. I know that, so for people like my like goal, there are like two goals I have. I really want to find like the best possible API to deal with state machines in a simple manner. But the other goal is to also learn people about the concept and help them like transition and understand it better from the perspective of what they already know. So if you think about like someone who doesn't know state machines and then they see TeamC, there's a lot of stuff there that like, what the hell is this? But in React states, you just say, okay, you have a reducer, but now you can call transition inside that reducer. And it's a lower, arguably a lower threshold. The question is like how valuable is it to have that intermediate step? For a beginner, arguably it's a good thing, but for someone who knows state machines, they would like jump right to TeamC. I don't know. I'm I'm just reflecting on this. Yeah. Okay, something I can reflect on when sitting with Oscar, him pointing. They're actually like tearing down some garages just across the lawn here. And that's like, it's Christmas multiplied by 10 for Oscar. So he's constantly pointing out the window and in his way shouting like tractor. He thinks all machines are tractors. But he's not able to say that. So he has this weird thing. But every time he sees like a tractor or a truck or whatever, anyways, it's funny for me. Cool, but no matter, I'm going to finish this implementation so that we actually have the same thing. Now we have the inference, which is great, and a much better way to express these transitions. And I'm going to reflect on that a bit as well, that we kind of lose that type safety. Well, what you could do though, so what you could, so what you could do, if you want that type safety, you can say pick state, state foo, bar. So now you just say this is the state I want to return from this, and then you get like the actual type safety, and you get the correct inference. And if you are able to like return two different ones, you just do this. But so that's the thing. You don't have to add that safety, but it's something you can do. It's like what's it called? Convention. Cool. Yes, I'm happy about that. So basically we just need to implement this thing. Yes. The good thing though is that now we actually don't need to type action or prev state. Like they're still there, but we don't need to type them. That's the good thing. That's the really good thing. Yeah, so we actually cleaned up. We just need these transitions, readable transitions. Because we don't use the action for anything on the outside. Nope. Nice. That is, oh, or do we infer? Yeah, so this is just. Yeah, so we still add them there. Because we need to read the actual action. Like that's the only way the effect can access this information. Because the effect only has access to the state object. So it will still access the action and the previous state to determine if it matches the transition. But we don't have to type it. That's the thing. Cool. Yeah, I don't have time to actually implement this, but we, oh, I should. But I will get that done. And then we have the same mechanism here. And yes, I concluded that if you want that return type safety, you just use pick state with the explicit state you want to transition to instead of having the generic state. And then you get these transitions. We're happy about that. And yeah, and then it's the bigger question, like why have React states and TIMSy? Yeah, it's just TIMSy has more of an exotic API. It's harder to sell TIMSy. And it's not about, for me, it's not about like creating a popular library. It's about teaching people about state machines and how they can be used. So I think it's easier to teach people, beginners, about state machines with React states. And then as you kind of move along, you would use TIMSy instead. I think. I don't know. Just a theory. Anyways, thanks for following along. Thanks for jumping in, Adam. This was fun. And yeah, this was a good stream. We'll talk later. Bye for now. Oh, what did I do? Oh, there we go. Bye.